Hello, good evening. Today I'm gonna talk to you about a little bit about the electric potential energy and some of the formulas we can use to measure them. But first of all, we need to know, of course, what it's or what refers to the potential energy. And well, definition it will be that it's type of potential energy that results from the Coulomb force and it's associated with the particular configuration of a set of point charge in a defined system. But even if we talk about the electric potential energy, this definition can be confused with the topic we're talking about. It's just like a general summary of what is the potential energy. And now we can discuss more focused, talk about the conservative force. And well, when a force is conservative, the work depends only on the initial and the final position. Now that we know that the potential energy depends on the position of the objects, we can express this work done by a conservative force with this equation, the first one we see at the top. And well, compared to the potential energy, the equation, um, a conservative electric force is when the work done by the electric force is the same when a charge changes position from A to B, regardless of the path it takes. We can let's talk a bit of the topic we're focused, the electric potential. Potential energy can be associated to any system in which a particle is located within an electric field and receives the action of any electrostatic force. This means that when a particle is with a positive or negative charge moves within an electric field, it will exert an attractive or a repulsive force that performs a work over this particle. To calculate the electric potential energy, we can use this formula. It's quite long, but we can use that to measure the electric potential energy on the electric field of any point of charge. And well, then we have the collection of point charge. Given a system of any number of point charge, the potential energy associated with a test charge at a point A will depend on the other charges of the system and their distance from the point A. The electric potential energy of a system of fixed point charge, according to Resnick, is equal to the work that an external agent must be performing to make the system, bringing each charge from an infinite distance. The charges are at rest in their initial and final position, and this can be represented with this summary of the equation. The original one is quite long, so we can use this to summarize it. Now that we talk about these little subtopics, the conservative force, electrical force, the potential energy, and with fixed charge points, we can talk about the electric potential energy as it is. The electric potential is also called just potential, and it's the electric potential energy per unit charge. In other words, the electric potential will tell us how much electric potential energy one coulomb will have if it's placed in a specific location. Now, how are we going to get this? With this formula or with the other version, that is this one. With these two formulas that are basically the same, we can calculate the actually electric potential energy. And well, now that we talk about a little bit the topic, we need to focus on the experiment. And for this, we're gonna use a couple lemons, a LED, uh, clips covered with aluminum foil, some copper cables, a knife, coins, and these ones. First of all, we're gonna take our lemons and we're gonna make a little holes on each side. Not too big, just enough for the coin, and that's it. All three of them. How I said, not too big, not too deep. We're not trying to cut the lemon, just to make a little hole in it. Ah, where did I make the hole on this one? Oh, right, it's all on the other side. Alright, now we're gonna take our coins and place it on one side, just like this. Every lemon needs to have a coin. Oh, wait, sorry. That's better. Alright. Ah, okay. And on the other side, we're gonna place these ones. Not too deep also, just enough to be placed on the lemon. Just like that. Lip side, just like this. And the reason of the clips is to make sure it's well taken, just like this. Just for reference, the coins are gonna be the positive ones. And it needs to be coin and then that one. Then all of them are gonna be grabbed like this, like in a circuit. It's kind of difficult to place the cable on the coin. Like that. Yes. And this one's gonna be here. The aluminum foil is just for gonna be just like this. Grab with some copper cables and carefully we're gonna place it whether it's the positive or the negative side. We're gonna grab that and it's supposed to light up, but I think mine is completely dead. It's just, it doesn't light up. It works. For example, the electric potential, it's a point on space that allows us to measure the electric field. And the difference of electric potential, it's the difference between voltage of 2 points. That's how this should be possible thanks to electric potential.